So what evidence do we have that solute particles do ionize in water or do break up into particles in water? One evidence is electrical conductivity. Pure water by itself, if you try to let water conduct electricity, it's a very, very poor conductor of electricity. Okay? So if you put something in water that makes it conduct electricity, that is evidence that whatever you put in the water is giving you ions in the water. Okay, so if you have ionic compounds and strong acids, you put them in water, they make the water conduct electricity really well. Whereas most other molecular compounds, if you put them in water, they're not going to conduct electricity. Another evidence of ionization is what are things that we call colligative properties. We can use this to actually determine the total concentration of solute particles. So for example, if you have a solution that had 0.001 moles of sodium chloride, from colligative properties, when we measure the colligative properties in the lab, we'll find that it will appear to have, instead of 0.001 moles of solute particles, it will appear to have 0.002, twice as many. So if you only put in 0.001 moles of sodium chloride, but your experiment tells you it seems to have 0.002, what does that tell you? That's evidence that each one of those split up into two. So each pair of sodium chloride gave you two particles in solution. So that's evidence of that's another evidence of ionization. So that's what we're going to talk about next. This might be a good time to take a break.